Expanding algebraic expressions. So, one way we can try and do large multiplication, so let's say 15 times 23. One way we can use this is by using the distributive law or distributive law, depending on how you pronounce it. So let's say, again, I'll use that same example. I'll say 15 times 23. Well, I could rewrite that as 15 times, and then 23, I can rewrite that as 20 plus 3. A lot of us often do mental math in this way, multiply it by one number, multiply it to another number, and then add them together to make them smaller numbers in our heads. But there's actually a word for it, and it's the distributive law. So I can say it's 15 times 20 plus 15 times 3. That goes to 15 times 20 that's a plus in that middle, plus 15 times 3, and that is going to go to 345. Alright, well, again, we're going to try and relate this back to algebra. Now, we know it's going to work because our variables and our pronumerals in algebra all represent real numbers. So, the same law applies to algebra. The same law applies to algebra. Let's say we want to find the area of the rectangle below. And I'll give myself a bit of room and I will draw it in. Okay, and then I'll add a red dashed line round about here. Let's say that this length over here is equal to 5. This is x, and that's 1. Okay? Well, we have a rectangle, so we know that the area is equal to length times width. Well, my length, that can just be this end here. So that is going to be 5. But the width, well, I have x, but I also have 1 at the top there. Okay, so what I'm doing is I have the two lengths. I'm going to add them together. And once I add them together, I'm going to be multiplying it by x plus 1. Because it's x plus 1. Now, I can rewrite this without that multiplication sign in between the brackets. And I'm going to do that just because it's going to make it look a bit nicer. So 5 outside of x plus 1. Now, the same way we did my example at the top, 15 times 20 and 15 times 3, I'm going to scroll back down and use the distributive law again. 5 times x, 5 times 1. I like drawing in the arrows just because it shows me what I'm doing. Again, you don't have to do it if you don't want. It is for the sake of the explanation, but I find it's really helpful when we're doing these problems. So it's 5x plus 5 units squared. Remember, we're still using area. Even though there's no numbers there, we still should put the units at the end. Okay, and that is how to expand an algebraic expression. It's using the distributive law. The distributive law states that a term outside of brackets, multiplies everything on the inside. So if we have A outside of B plus C, again, these represent real numbers. So they follow the same laws as real numbers. A multiplies by B, A multiplies by C. That is going to equal AB plus AC. Remember, AB is the same as A times B. We just don't have to write that multiplication sign there when we're multiplying variables. And as well, we have A, B, take C. Well, that's going to be A, B, take away A, C. Because there's that negative sign now that we have to think about. We also have to take into account if the number outside of the brackets has a sign as well. So right now the A is only positive, and so that doesn't change anything. But if the sign of the term outside of the brackets is negative, so if the outside term is negative, it changes all signs inside our bracket. Okay? So if the number out front of my brackets is negative, then it changes the signs of everything inside of the bracket as well. So if we have negative 2x outside of 4x, take 3. This is probably a more typical example of a question you guys might see. So we negative 2x times 4x, negative 2x times negative 3. Well, negative 2x times 4x is negative 8x squared. Negative 2x times negative 3 gives me positive 6x. Okay? The negative 3, the sign changes to a positive. Then positive 4, the sign changes to a negative. So just be aware that it's going to be a little bit different once we have negatives in our outside term. So we want to expand the following. Alright, so we've got to give a couple of examples. We'll have 5 outside of x take 11. We're going to have 4 outside of x take 3y. And then we're going to have 3 outside of x plus 2y. Take away 3x plus y. Okay. So for my first one, quite simple. Just distribute the 5 to every term. 5 times x gets me to 5x. And 5 times negative 11 is negative 55. So it's 5x take away 55. 4x, negative 12y. 4 times x gets me 4x. Take 12y. Again, these are both quite simple examples. Now, this next one is where we have to consider expanding, and then we can see we're also going to have to simplify at the end, because I've got 2 brackets. So let's expand that first one. 3 times x gets me to 3x. 3 times 2y gets me to 6y. And now, there's no number out in front of that bracket, but there is a minus sign there. The coefficient, the number outside of that bracket, is actually a -1. We can multiply 1 by anything, and it will still be itself. So we always have to remember that it's actually going to be a 1 there if there's no number. And then we have to take into account the minus sign as well. So we're multiplying all of this by -1. So what is 3x times -1? Well, it's -3x. And then y times -1 is -y. Now we need to link all of our like terms together. So 3x and 3x are going to be like, and there's a minus sign in front. And then 6y and y are going to be like, and there's a minus sign out the front. Well, 3x, take away 3x, that's just going to be 0. So I'm not going to write that. And then 6y, take away y, is 5y. And that is how we expand algebraic expressions.